23. Okay. Okay, are you able to see my screen?
Yes, sir, visible.
Okay, but thank you. Yeah, guys, very good morning. I think this is the first class after midsem exam, right? So midsem exam we covered 4 topics. Just I go through few, I mean some 3 to 4 minutes recap. Then we start today belt rise. Okay. So I think that assignment part, the 4th unit assignment part, not yet submitted. Okay, actually I told your CR to extend the deadline. I will extend the deadline till tomorrow. Okay, I mean I didn't do the change in date in the LMS. After the class, I will do it. Please submit the assignment before tomorrow 12 p.m. Okay, tomorrow midnight. That is the for assignment 4, and also some students not yet submitted the assignment 3. I mean there are 20 students I think not submitted, 20 or 24 students, 24 students not submitted assignment in the 3rd chapter. So I will give the chance to tomorrow to who are not submitted, please submit the assignment. Tomorrow it will be closed the portal. You cannot submit the late submission. Kalyan, are you in the meet? Are you in the class? Kalyan.
Yes, sir, I am there.
Okay. I will extend it today. Okay.
Okay, sir.
Okay. Now, this is our standard figure. So this figure I am going to consider for every chapter. Okay. So in this figure we can say that, I mean within 5 minutes we can explain our DTE content. That's what I am holding this figure every beginning of chapter. Now, just to recap what we discussed as of now, we discussed shop already, right? Shop design, shop and keys design. This is shop we discussed in the early, I mean before the midsum, right? For shaft design, shaft diameter based on strength and rigidity, based on bending moment and twisting moment, right? We discussed the shaft, and also we discussed the shaft coupling. I mean, what is the use of shaft? We have to transmit the power. That is that purpose only we are using the shaft. Then based on the power transmission, we define the shaft diameter. Then the shaft must be connected somewhere else. Then the shaft was connected to the, I mean, power transmission, I mean, items like gears, pulleys, right? Even later we are going to discuss I mean, chain mechanisms, sprocket. All are connected with the shaft. When the power, now how it was connected, that how the power was transmitted, with the help of the gears, with the help of the pulleys, with the help of the couplings, right? Couplings we discuss in the same chapter. We discuss the different types of coupling, flange coupling and muff coupling. For example, flexible coupling and rigid coupling. Broadly we discussed, I mean broadly we can classify flange coupling and muff coupling, I mean rigid coupling, flange coupling and rigid coupling. Then the couplings and gears and pulleys, how it was connected, we discussed using keys. Using keys. That's what's first chapter. Okay. We discussed different types of keys. The keys, different types of key, Kennedy's keys, I mean sunk key, rectangular sunk key, square sunk key, shadow key, I mean, right? I mean, these are the things we discussed in the first chapter. The second chapter, second chapter we discussed gears, right? First, I mean, saw sharp couplings and keys. First chapter. Second chapter we discussed that gears. I think gears, what different types of gears. Now the gear is now, this is the first chapter. Soft keys. Then second chapter was, I mean, gears. Now, with the help of the keys, the gear is securely connected with the shaft, right? Now, with the help of the gears, the power is transmitted from one place to another place. This means one shaft to another shaft. I mean, here the power transmission can happen short distance. Now, this is now this is the gear. The pinion is connected here for transmitting the power from gear to pinion, right? We discussed different types of gears, bevel gears, spur gears, helical gears, but especially we discussed spur gear design. In the spur gear design,
Hello, sir.
yeah, some mistake. Actually, in the spur gear design, we discussed based on bending strength, based on wear strength. We discussed the gear chapter. I mean, based gear design, spur gear design based on bending strength, based on wear strength. We discussed, and the same concept, I mean, the same design concept we used to solve the problems. And similar concept we extended to bevel gears, and we discussed only the concept. We didn't discuss the problem with the bevel gears. Okay, so but the same concept only we are following for the design of the spur gear, helical gear, those things. That is second chapter. The third chapter, now the gear is that, I mean, shaft is used to connect the other components such a way that like gears, pulleys, right? But the shaft also must be supported while transmitting the power. The shaft must be supported in appropriate place. Hence, we are using here the shaft may be supported here. I mean, the shaft must be supported as well as the shaft should be a free rotation. This is the supports. Okay. Now this is second chapter over. Now we are in the third chapter. This is this is second chapter. Third chapter and fourth chapter. The third and fourth chapter, how the shaft to be freely rotated with the help of the other mechanism. That mechanism is called bearings. With the help of the bearings, the shaft securely held as well as power is transmitted. I mean, the bearings allow the shaft to free rotation at the same time to, I mean, support the shaft securely. Okay, so hence bearings. In the bearings, we discuss journal bearings and ball bearings. Ball bearing or rolling bearing all are same. So ball bearing, I mean rolling bearing or anti-friction bearing. In the journal bearing, the sliding contact, right? Line contact. Journal bearing surface contact, right? And roller bearing line contact and ball bearing point contact. So while power transmitting in the while connected with the shaft, that's what we discussed. And going to Sorry. Just a minute. Suddenly changed this. Now that is roller bearing and ball, journal bearing and roller bearing. I mean ball bearing or rolling bearing, same. It's a ball bearing and rolling bearing is under anti-friction bearing. About and that's what we discussed in the third chapter, and we discussed Petra-Patter's equation and Strebach's equation for bearing design. Okay, right? And I mean Reynolds equation, Petr's equation, Reynolds equation we discussed in the bearing, and I mean we used the manufacturer catalog book how to use the bearing parameters. I mean this I mean Sommerfeld number, bearing length to diameter ratio, friction variable, coefficient of friction variable, pressure ratio, and minimum oil fill thickness. These are the things derived. These are the things obtained the values from the experimental studies. So then that made it in the form of table. We have been taken from the table and we are designing the bearings. But those information how they obtained, I mean that first there are the scientist I mean not Sommerfeld, but there is a Reynolds equation. Reynolds equations derived this bearing behavior in the form of partial differential. The another two researchers came after his tenure. Another two researchers came and used that partial differential equation and solved them, and then finally used and experimentally collected the data using that equations and for analysis the bearings. Then they made it standard table, and we are using the standard values for our design the bearing concept, bearing parameters. And now, while discussing bearing, we can't discuss only bearing. The bearing behavior is very important. Based on where bearing behavior is based on the lubricant oil. We cannot avoid the lubricant because the bearing design also depends on lubricant behavior, lubricant oil behavior, lubricant fluid behavior. That's what we discussed, coefficient of flow variable and flow variable. How much flow variable, in flow variable Q by QS, in how much quantity of lubricant to be required in the bearing, inside the bearing, and how much side leakage inside the bearing. That's what we discuss. And while sending the lubricant, then how much heat is generated? How much heat is generated in the bearing? Those things we discuss. I mean amount of heat generation. How much heat is increased, not generated, increased due to the friction between the bearing and the bush surface, right? Then based on the temperature increment, we can define the lubricant type. That's what we discussed in x-axis temperature, y-axis in lubricant viscosity in terms of centipoise, right? That's what we discussed. Lubricant behavior, x-axis in temperature, y-axis in viscosity, in centipoise, right? Now here we discuss like I mean, this is the SAE 10, SAE 20, SAE 40, like that. Now, in this SAE 10 is, I mean, Society of Automobile Engineers. Automobile Engineers SAE 10 means, SAE 10 is nothing but it's, I mean, what is the meaning of SAE and SAEW? Please, someone tell that. Just to recap, SAE 10 and SAE W10W, like that we discussed. What is the meaning of it? Or SAE 40?
SAE
What?
is Society of Automotive Engineers, sir.
The W representing?
Winter.
Yeah, thank you. Very nice, very nice. I mean, the viscosity of oils, they discussed between two temperatures. One is, I mean, 100 degree, I think, room temperature, and 212 Fahrenheit. Because standard, based on the industry standard discussed. Okay, these things we already discussed. I mean, how to define the, I mean, how to choose the lubricant properties, and we also discuss some binders to how to improve the quality, improve the performance of the lubricants, adding some binders. We discuss, because the lubricants, when we are discussing bearing design, when we are discussing bearing, or when we are designing the bearing, either roller bearing or ball bearing, most important thing, lubricant. The lubricant, based on lubricant behavior, also behavior, we are designing the bearing. But the load, how much load is acting, how we are defining the diameter of the bearing, I mean, that is also depends on load acting in the shaft. I mean, for example, the load is acting here, radial load and tangential load here. Here, this is the radial load. Sorry, this is radial load. This is a tangential load. The same load will be transmitted in the shaft, in the bearings, because now the bearing is looks support as well as, I mean, to allow the free rotation of the shaft. Hence, the shaft diameter, I mean, outer diameter of the shaft going to be internal diameter of the ball bearing. Okay, anti-friction bearing. So we discuss up to this chapter 4. Now we come to the next chapter. Now, power transmission using the belt drive. Now, earlier we discussed, I mean, gears. In these gears, the pinion and pinion gear, the gear and pinion, it was how it was connected and how it was power is transmitted. We discussed in the earlier class in the chapter 2. Now, in the actually in the DTE, before mid exam, we never discussed about the power transmission using belt drive. I mean, even though we discussed the power transmission belt drive, but we didn't discuss about design of the belt. Now, design of the belt. Okay. Now, the design of the belt is very important for mechanical engineers. There are so many applications. We will see what are the applications using belt drive mechanism. Okay. Now we are going to discuss now, this is a belt drive. Now, belt drive, we can say that there are two types of mechanism, power transmission mechanism. Broadly, we can say that rigid power transmission mechanism, flexible power transmission mechanism. Now, gears are under rigid power transmission mechanism. Our belt drives are under, I mean, flexible power transmission mechanism. Now, we are going to now, I mean, next 5 to 6 classes, we are going to concentrate flexible power transmission mechanism, belt, ropes, and chain drives. These are under flexible power transmission mechanism. We already discussed the rigid power transmission mechanism. Now, in the flexible power transmission mechanism, we already discussed this pulley diameter. I mean, pulley diameter. I mean, even you know, right? I mean, driven pulley, driving pulley, speed ratio. Those things you already know. Now we are going to concentrate different types of belts and how to design the belt type parameters based on the power transmitting capacity. Okay, are you clear? Any doubt in this? Now I come to this belt drive. Guys, actually, this is Very simple. That's what I didn't put a point by point. If I later I will give the point by point anyway. But listen, just this is very simple. You can go through that. You can get easily the points. But anyway, I would like to tell you here the only key point. Okay, you can easily understand also. This is not a big one. Not a difficult statements and sentence. You can easily understand. Anyway, I take to you for only, I am going to tell you the key point. Okay. Now the flexible type. What are the flexible type for power transmission? Belt drive, chain drive, and rope drive. These are the flexible types, flexible drives. Okay. Now rigid drives, gear drives is called rigid drives. These are under non-flexible power drive mechanism. In gear drives, there are driven, there is a direct contact between, driving and driven shaft. I mean, here the direct contact means that the driving shaft and driven shaft connected with the gears and the pinion, or vice versa. Okay, this is a mesh together. No intermittent mechanism, no intermittent link. Hence, this is, I mean, rigid drive mechanism. The pinion and the gear are coupled to gear are meshed to each other. Here, no intermittent mechanism, no intermittent mechanism or no intermittent link, and this is called a rigid type mechanism. So you may expect that such a kind of question subjective. I mean, in rigid, I mean, intermittent mechanism or intermittent link may not, it will not be there in the rigid drive mechanism. Now come to this. Now a rigid drive, there is a two component. I mean, rigid drive, one is driven, for example, driven gear and a driving gear. For flexible drive mechanism, there are three components. One is driving gear, sorry, driving pulley, driven pulley, and belt. We need a three component. Okay. Now in flexible drive, in the flexible drive, we need three components or three mechanical items. One is driving pulley, driven pulley, and belt, endless belt. Okay, these are the things to be required. Now in, that's what we are telling here. Okay, just I highlight here. In flexible drives, this is the link. Okay. Now I come to this. In flexible drive, what happened, how the mechanism is functioning, right? First, the driving pulley rotates. The driving pulley rotates, then the driving pulley rotation going to be transformed in the form of linear motion with the help of the belt. That linear motion further transmitted in the form of rotary motion when the belt is connected with the driven pulley. Got it? Yeah. That is the, we are saying here. Now in this, the first converted, the driving shaft is the first converted rotary motion of the belt chain, then again converted into rotary motion of the driven shaft. And this is the, flexible mechanism and flexible drive mechanism and rigid drive mechanism. Concept. In rigid drive mechanism, the power transmission from driven shaft to driving shaft to driven shaft, rotary motion to rotary motion. But in flexible drive mechanism, power transmission from driving shaft to rotary shaft, driving shaft to driven shaft is rotary motion to linear motion, then linear motion again converted into rotary motion in the flexible drive mechanism. now now see here, this is the some advantages as compared to our gear drive rigid mechanism. Now see here, this is a long distance, the power can be transmitted. Long distance can be, the power can be transmitted long distance. Then The intermediate link is flexible. The belt is flexible, absorb the shock and loads during power transmission from driving shaft to driven shaft. Then the flexible drives provides considerably flexible here. I mean, then it can be, it need not to maintain uh, accurate alignment, because the power transmission drive we are using here, belt, the belt can be easily aligned based on the, suppose some misalignment between the driving shaft and driven shaft, then based on the misalignment the belt automatically aligned. So these are the, that's what the advantages of the flexible drive mechanism. Okay, and I mean the life of the mechanism, the life of the belt is less, right, and low efficiency due to loss of power when we, because the belt is, the slip is going to occur. I'm talking about the disadvantages of this belt drive mechanism, I mean flexible drive mechanism, especially belt. I mean, short life of duration and low efficiency due to loss of power. How the power is lost? Due to slip effect, then due to, I mean, due to slip effect, and the frictional effect. Okay, these are the things. And the power transmitted. These are the disadvantages now, and it will be required more space also. I mean, required more space, and also, I mean, related, the velocity ratio relatively small as compared to rigid drive mechanism, compared to gear mechanism, and the velocity ratio is not a constant, not a constant in that sense, due to I mean vibration of the belt, the velocity is velocity ratio changes. Due to slip effect, the velocity ratio changes. Perhaps if you are connecting the belt to a driving pulley and driven pulley today, after 1 month continuous functioning, the belt, due to wear and tear, the slip effect going to be changed. That means the friction, coefficient of friction between the belt and the pulley going to be changed slightly. That also causes the velocity ratio effect, change in velocity ratio. Okay, that is, these are the things, the disadvantages. Okay, now power transmission here in belt drive mechanism, power transmission due to friction effect between the belt and pulley, and slip can occur. These are the disadvantages in the belt drive mechanism. Okay. And belt drive can smooth operation. Okay, and the belt transmit the I mean only a less load transmitter as compared to the gear drive mechanism. Okay, because gear drive mechanism is a, so I mean, is a solid meat, the material whatever we design the gears or machine the gears are in solid medium. But in gear belt drive mechanism, it's like, it's not a solid medium. The belt is kind of a canvas and rubber and fabric material. So obviously it can be used for less power transmission. Okay. Now, some more disadvantages. Yeah, this anyway, like it will all occupy large space, more space, the velocity ratio not constant, heavy load shock. Okay, and less power. I mean, there is a considerable loss of power. I mean, low efficiency. I mean, the efficiency low due to loss of power in the belt drive mechanism. You can go ahead and get it more information. Okay, some disadvantages and the disadvantages of the belt drive. The important things what you have to know here. Belt drive mainly used for electric motor. Where is the application? Belt drive we are using electric motors, automobile machines, tools and conveyors. We are using belt drive. It's not limited. Even electronics people, they are using small motor, they are using small belt mechanism. Maybe the belt is a cross section, maybe different. Okay, depends on application. Now depending upon the shape and cross section of the belt, now we can class, we are going to discuss the I mean, mostly we are going to concentrate these two belt only, flat belt and V belt. Flat belts are, I mean, you know, right? You might have been studied already. The second year is KOM, kinematics of machinery subject. The belt is flat belt is a rectangular cross section, and the V belt is trapezoidal cross section. V belt is a trapezoidal cross section. Now we are going to discuss in detail in later how to design the flat belt and V belt, and based on orientation, based on application, the belt is going to be defined, like for example cross belt and open belt. Okay, but in trapezoid, I mean in V belt we can't use for cross belt application. Only flat belt can be used for cross belt and open belt application, cross belt application. Trapezoidal belt always open belt type. Okay, now and now the belt, it can be easily replaced. Flat belt, what is the, I mean flat belt advantages compared to V belt? I mean flat belt can be easily replaced, different velocity ratio can be obtained using stepped pulley easily. But like even cross belt, I mean even that V belt also can, V belt also used, V belt also we are using for different speed mechanism, to obtain different speed mechanism, especially in lathe mechanism, lathe machine. But a complex design, the pulleys are complex design as compared to flat belt mechanism. Okay, but both belt can be used for, I mean different can be used to obtain different speed. Okay, and easy design and fabrication. Flat belt, the flat belt can be used up to 15-meter distance. Okay, the flat belt can be used up to 15-meter distance can be used, and I mean efficiency of the flat belt is greater than the efficiency of the V belt. This is very important information. You may expect in the uh, objective type or any competitive exam also you can expect. This is flat belt. V belt mechanism. The efficiency of the flat belt is greater than the V belt mechanism. Okay. What are the disadvantages? Flat belt mechanism. Low power transmission. The velocity ratio of the belt is lower. I mean low power transmission. Velocity of the, I mean velocity of the, velocity ratio also low. The velocity ratio of the belt drive is lower than V belt drive. Okay, the flat belt drive have large dimensions and occupy more space. These are the disadvantages compared to V belt. Flat belt can generate, I mean flat belt generates more always noise as compared to V belt, because when we are trying to transmit the power more distance, obviously noise is going to be presented in general. Okay, that's what. And in general flat belt drives, we cannot use, I mean flat belt we can't use easily in the vertical power transmission. Suppose, I mean my actually here our driven pulley and driving pulley is oriented in vertical direction. In this case very difficult to use flat belt for power transmission from, I mean here to here, from the, I mean driving pulley to driven pulley. It may possible to falling down. And also, I mean at initially, suppose when the belt drive mechanism knew that the tension will be more, but after some duration the belt is going to be deformed. During that time the power transmission is also going to be difficult, and it cannot be it cannot expect a stable connection. Hence V belt is better in this, I mean in this condition. So that's what we are selling, that then flat belt drive, I mean, are horizontal and horizontal. It cannot be vertical. But in V belt, we can use vertical power transmission also. We will see why it is. Because the friction, coefficient of friction between the belt and pulley is very important parameter for power transmission capacity. So in flat belt drive, the coefficient of friction between belt and pulleys happened in the flat surface, while this contact with the flat belt surface and pulley surface. But in V belt, we are going to use this trapezoidal shape. The cross section of the uh, belt is trapezoidal shape. Similarly, the same identical shape we are going to follow in the pulleys. Hence, the coefficient of friction is very high due to the wedge action. The wedge action because of the trapezoidal cross section. Hence, it can be transmitted more power, also less slip effect in the V belt. Hence, V belt can be accessed any direction, vertical direction or horizontal direction. We can easily transmit the power from driving pulley to driven pulley. That's what telling that. Now, where is the application here? See here, I mean, this is very important. You should know some few applications. Now we are using flat belt. Where we are using the flat belt? Just see here. I mean, we are using flat belt for, I mean, in belt conveyors, backing machinery, and line back. I mean, clay machinery, crushers, sawmills, floor mills, the textile machinery, and line shafts. Line shafts. I have, and the last. I think before midsem we discussed. I shared some videos also. Line shaft. The line shaft are connected with the main main motor, then the lines are going to have more than two pulleys, right? The each pulley going to be accessed with a different mechanism with the help of the belt. That's what lines are. The lines out also, the lines out we are using flat belt for transmitting the power for transmitting the power to different mechanism or accessing the different mechanism with the help of the belt. Okay, flat belt, right? Okay, now this is the flat belt, and so I already told you that here. First see here. I mean, now the flat belt and V belt of the wind, there are some difference. I mean, as I told you that some of the friction force, the force of friction between the surface of the V belt, surface of the belt and V grooved pulleys higher due to wedge action. I just now I told that. Hence, where the coefficient of friction, the friction force is high, we able to transmit to more power because the wedge shape, due to wedge shape of the V belt, the more coefficient of friction. Hence, the more coefficient of friction, then the friction resistance high, then we able to transmit more power. Okay, that's what. And V belt only can be used for short distance power transmission from, I mean, driving pulley to driven pulley. It will be a short distance only. I mean, these are the things. Please go ahead. You can get it more information now. What is the disadvantages in this V belt drive or the flat belt drive? It's a complicated design. Okay. Yeah, the points I missed out. 1 minute. Yeah, most of the thing I told you that in the advantages here. I mean, that the friction has high due to wedge action and also smaller arc of contact. I would like to show you this. Yeah, first the belt I will show you. Yeah, see here. Then you can easily understand. This is a wedge trapezoidal cross section. Here the coefficient of friction high due to more in contact region. I mean, due to wedge action. Sorry, due to wedge action, the arc of contact also small. Hence, the coefficient of friction is high. The friction resistance is high. Then able to transmit more power. Okay. Now, I mean, the other thing is it can be transmitted short distance. Now, V belt is almost the V belt is a negligible slip effect and a constant velocity ratio. V belt. constant velocity ratio. And I mean, this belt, it can be accessed at any direction. Suppose this is now this is a driving shaft, and driven shaft looks like horizontally oriented. It may happen, the driven shaft and driving shaft, it may happen, I mean, it may be in vertical direction, it may be oriented vertically. During that time also, the power can be transmitted safely using this V belt. But flat belt, very difficult to vertical power transmission. We have to maintain always appropriate tension. Even though very difficult, even though we can use, but we have to maintain always appropriate tension in the flat belt. That's what we are using idler pulley. You might have been studied in the idler pulley to adjust the slack side and tight side tension for transmitting the power, for for maintaining the appropriate tension, for transmitting the power. In the the flat belt, we are using idler pulley. Here we are not using idler pulley. These are the advantages in the V belt. And what is the disadvantages of V belt? Just we see a few points, then we go for the types of cross section of the belt. Okay, now see here. Actually, we had already discussed one more point. Here, the efficiency flat belt is always higher than the efficiency of the V belt, and the grip also. The grip is one of the important property, right? In the mechanical property, grip is less grip in V flat belt, in less grip, slip effect, coefficient of friction. I mean, this is always high. The grip is high in V belt. Slip is negligible. Negligible. Okay. Coefficient of friction. The frictional force is high as compared to flat belt. And power transmission. Now, power transmission. More power transmission. Efficiency. V belt efficiency flat belt is greater than V belt. That is these are the things. Okay. Now, complicated design. Because you may expect this type of questions, maybe difference between the flat belt and V belt comparison. Okay. Now, V belt is now where we are using mostly in the V belt. V belt, some places where we are using the V belts. V belts, we are using electric motor, prime movers. We are using prime movers to drive the compressor. You might have been seen in generation, power generator, right? The prime movers and generators connected through the V belt, and the pumps, water pumps, fans, and positive displacement pumps, blowers, and machine tools. Machine tools, lathe machine. Lathe machine, you might have been seen that means the main spindle, the headstock spindle, is connected to the power transmitting mechanism. Connected to the motor with the help of the headstock spindle connected to the motor pulleys, stepped pulleys, with the help of the V belt. With the help of the V belt. There are now another thing, the velocity ratio. Velocity ratio for flat belt is 4:1, but V belt velocity ratio is now 7:1. But in chain drive velocity ratio is 15:1. 15:1. Now, these are the things difference between the flat belt and V belt. This kind of this kind of application you should know, and this information you should know. It will be very useful in your competitive exam as well as our objective type exam. Okay. Now we come to this rope drive. I mean, just we discuss only as of now flat belt and V belt. Now briefly we are going to discuss about the rope drive. See here, the diameter. This is the round belt. Can you tell me where we are using this round belt? One simple example. Where we are using? The round belts usually 3 mm to 12 mm diameter. Then, I mean, the diameter, minimum diameter of the smaller pulley of round belt is 30 times the diameter of the belt. This is the diameter of the belt. But where we are accessing this belt, the round belt, that pulley diameter is 30 times of the diameter, at least 30 times diameter of the our rope. Where we are using D divided by D. This is the D is nothing but round belt, round cross section. Okay. Now there are two types we already discussed. Now we are going to discuss the cross section of the belt, and the belt construction we are going to discuss now. Now here also, see here, this is a pulley. This is the round section, round groove pulleys. I mean, with the trapezoidal with the 40 angle. These are the standard angle, 40 angle, and this is the round off pulley. See here, this is the round off pulley. This is while we are using round belt. Okay, this is round off pulley. Now see here, here. I mean, as compared to flat belt, here also less slip effect, and the belt is securely sitting on this pulley for transmitting the power. Okay, and less slip effect. Because of that, the pulley mean the belt, the round belt cross section is securely sitting on the pulley surface, hence the slip effect is less as compared to flat belt drive. Also, the frictional area is more as compared to flat belt, hence the slip effect also, hence the slip effect is less. Okay. Where we are using we are using, this is a round pulley, I mean light duty application. Also we are using dishwater dryers, showing machines, and vacuum cleaners, and see here we are using vacuum cleaners. Also we are using in the, I mean, tailoring machine. We are using, no, this round dropped out. I see here. We are using round belt here. See here, this is the round belt we are using here. But the round belt where we are accessing our pulley diameter must be greater than the 30 times of the diameter. See here. Okay. Now this is the flat belt, the application. Now this is the prime mover connected with the power generator. Okay. Sorry. The prime, this here, the prime mover and the power generation connected with the flat belt. Now this is the V belt. Now V belt mechanism. Now see here, this is another mechanism. I mean timing belt. Timing belt is like it's a toothed belt. Timing belt also called a toothed belt. Our I mean our IC engines, we are accessing the valves, inlet and outlet valves with help of this toothed belt and toothed pulley. It's also called a timing belt. Okay. There are a few applications I have been put here, and this is the flat belt with idler pulley. Now, flat belt with the crossed cross belt application. Now, what is the difference between open belt and cross belt? Why do we need this to cross belt? Please, someone tell me that. Guys, please. This is the uh, open belt.
Sir, police rotate in opposite direction.
Yeah. I mean, thank you. I mean, this is here that because in gear mechanism, rigid mechanism, driving gear, driven gear. I mean, gear or we can say gear or pinion. Gear and pinion are rotating in opposite direction always. But in belt drive mechanism, especially flexible drive mechanism, the driving wheel and driven wheel or driving pulley or driven pulley, sorry, driving wheel and the driven wheel going to be rotate in opposite direction. You may say that some books they mention pulleys. The driving pulley and driven pulley will rotate opposite direction when we connected the belt simply in open section. I mean simply connected the belt on the driving pulley and driven pulley. Both will rotate same direction. Driving pulley and driven pulley rotate in same direction. But if we want to change the direction of rotation, each direction of rotation from pulley to one pulley to another pulley, hence we are going this kind of mechanism, cross belt drive mechanism. Hence now that driving pulley and driven pulley, the rotation is going to be changed. Now see here, now this is the idler pulley because after some duration the belt going to the tension due to deformation, the belt length may be increased. Then we would like to maintain appropriate tension. We are using this idler pulley based on the belt change in deformation. We want to make the idler pulley can be moved up and down to maintain appropriate belt tension for transmitting the power. So idler pulley we are using here. Now this idler pulley not only maintaining the appropriate tension of the belt, the idler pulley may be connected with the other mechanism to drive the mechanism. For example, the idler pulley you can connect with the dynamo for generating the power. So it will act as a mechanism. Some other it will the idler pulley it will be activated some other mechanism. The same time to maintain the appropriate tension in the belt. That's what we are using idler pulley. Now lathe machine we are using plumbing V belt. See here, this is the mechanism. This is a power transmission. Now this is a power generation here. The more electric motor connected to the stepped pulley. The stepped pulley connected to the spindle. Connected to the spindle. Connected to the spindle. I mean, with the help of the through belt drive, V belt drive. Okay, the connected through V belt drive, but here in the I mean the spindle also connected with the stepped pulley and our motor also connected with the stepped pulley. So based on this, suppose for example here the smaller diameter of the pulley is connected, here bigger pulley is connected. Now the spindle speed is slow. Suppose now this is a bigger pulley. Now the belt is shifted here. Now the belt is shifted here now to this
Excuse me, sir.
pulley. Okay. No? Yeah.
The time
Time
is
up,
all.
sir.
Yes.
I can't stop it here. I stop it here. Now the belt is shifted to here this pulley. Then this is a diameter is more. This is a diameter is a D1. Then what is the speed ratio? D1 by D1. Then now it will be a more speed can be obtained in the spindle. So this is that's what we discussed already in the KOM. Now just I recap some of the information you already discussed. You should now we are recap. That's all. Okay. Idle pulley I already told that. Now I stop it here. Okay, slowly We move to the next content. Tomorrow class we have 10 to 11. Let's see. Yeah, I stopped here. See, this is the types of belt, and we based on cross section. This is a trapezoidal cross section. This is a round cross section. This is the rectangular cross section. This is a two-tooth belt. Two-tooth belt can be used for, I mean, in the valve activating mechanism. This can be used for in the long distance power transmission. This can be used for the short power transmission distance. This also can be used for long power transmission distance in the rope drive, the circular cross section. But it can be, especially circular cross section, can be used for, I mean, light duty applications. Okay. Okay, I stop it here. We see the next class. We will see these remaining things. Yeah, please. If you have any doubt, please go ahead. Do you have any doubt?
No, sir.
Yeah, Kalyan, only how many students were there in between the class? Hello? Kalyan. Hey, Kalyan, are you there in the meeting? Hemant, Amarnath Biswal. Hello? Hey, guys, are you there in the meeting or not?
Yes, sir.
How many students were there in between the class?
It was, I think it's 55.
55. So the number of students always less. I mean 60, maximum 60 or 61. Always at least 20, 22, 20 to 25 students not attending the class. So the only solution I would to resolve this problem, I have to take attendance. Okay. Tomorrow class I will follow the attendance. I'm not going to follow the attendance in the WebEx. I want to take physically attendance tomorrow onwards. Okay, I'm closing the meeting.
Yes, sir.
Thank you guys.